going to be intimidated. So let's go ahead and pick up here. All right, 2 says ethene, C2H4, with a molar mass of 28.1 grams per mole. May be prepared by the dehydration of ethanol with a molar mass of 46.1 grams per mole using a solid catalyst. A setup for the lab synthesis is shown in the diagram above. The equation for the dehydration reaction is given below. So they give me the equation. Notice they give me a delta H value and they give me a delta S value. Okay? What do you think they're going to ask me to find at some point in this problem? Delta G. Okay? A student added a 0.200 gram sample of C2H5OH to a test tube using the setup shown above. The student heated the test tube gently with a Bunsen burner until all of the C2H5OH evaporated and gas generation stopped. So this lets me know the reaction went to what? Completion. Okay, the reaction went to completion. When the reaction stopped, the volume of gas of collected gas was 0.0854 liters at 0.822 atmospheres and 300 Kelvin. The vapor pressure of water at 305 Kelvin is 35.7 torr. A says calculate the number of moles of C2H4 gas. Okay, what equation do you think I'm going to use for this? PV equals nRT. Now there's something here that's kind of tricky. So when you look at this, what numbers do you think you're going to use for PV equals nRT? Correct. We look at these three numbers and we think this is what we're going to use, right? Those three? Okay. There's a problem with this. Okay. Why is there a problem with this? Because they told me that the total pressure of the gas was 0.822 atmospheres. Notice in the equation I have what? Two gases. Okay? So this is the pressure of the ethane and the water. Okay? I only want the number of moles of what? Ethane. Right? Okay? So I've got to figure out what the pressure is of ethane. Well, this is the total pressure. There. Okay? This is the pressure of the what? H2O. So how can I get the pressure of the ethane? Convert the torrs to atmospheres and then do what? Subtract. Do we see that? Yes? We do see that? Okay. All right. So, then we start freaking out because we go, I don't remember how to convert torrs to atmospheres. I don't remember that. So then I'm going to pull out my handy-dandy AP Chemistry equation sheet. Yes? Yes. Everybody pull out your handy-dandy AP Chemistry equation sheet. Okay? What do we notice on that long list of things that it gives me on my handy-dandy AP Chemistry equation sheet? It tells you 1 atmosphere is equal to 760 torr. So can I convert torrs to atmosphere? Yes. What do I need to do that? Divide by 760. Okay? So I take, hang on 1 second. Something's out with my smartboard. All right. Oh, geez, that's not good. That's not what we wanted to happen. That's not what we wanted to happen at all. Nope, don't want to do that. Down. All right. So we're going to take 35.7 we're going to divide it by 760. And how many atmospheres does that give me? Let me see. 35.7 divided by 760 is equal to, I would go there, atmospheres. Okay. So now how do I get the pressure of ethene? Subtract it. So for the pressure of ethene, I'll do 0.822 atmospheres minus 0.0470 atmospheres. So the pressure of ethene is what? Atmospheres. Now can I find the number of moles of ethane that was produced? Yes, what equation am I going to use? PV equals nRT. So PV equals nRT. So that means N is equal to PV divided by RT. And what answer do we get? 2.64 times 10 to the negative third moles.
So that doesn't answer problem.
That answers this one that are actually produced. So you would have gotten 1 point for getting the actual pressure, and then 1 point for getting the number of moles. All right, so that's how many moles were produced. 2 asked me that would be produced if the dehydration reaction went to completion. Okay, does everybody have this? Because I'm about to erase it. You got it? I read the problem like it went to completion, but they're saying it didn't. So I say, all right, so if it went to completion, how much of this did I start with? 0.200 grams, right? This is a 1:1:1 ratio, correct? So however many moles of this I started with, if it went to completion, that's how many moles of ethene that I should what? Produce. Does everybody see that? So what do I do to get this to see how many moles of ethene would be produced if it went to completion? I just need to change this to what? Moles. So I would say 0.200 grams of C2H5OH, and then 1 mole of C2H5OH. There are, how do I figure out how many grams? I use the periodic table, correct? Huh? Oh, it did give it to us, didn't it? Did it? Yep. It gave it to us. 46.1. And then for every 1 mole of C2H5OH I have 1 mole of ethene. So that makes all of that cancel. So how many moles would be produced? .34 times 10 to the negative third moles. and you would have gotten +1 for that. Is everybody following me so far? Does everybody remember how we did the mole to mole in the beginning? We're going to go over that right quick, how we used to do it. I'm going to have to restart my computer. It's real slow. Real slow. All right, so we would take the equation, C2H5OH goes to C2H4 plus H2O. Okay, and we would put the molar masses on top. So this one we know is 46.1. They gave us ethanes was 28.1. Okay, and waters, they didn't make you know, but I just know off the top of my head it's 18.02. So molar mass goes on top. Okay, why? Because we know if they give us grams to get to moles, all we have to do is what? Divide by molar mass, right? So if you go ahead and find your molar masses, just save yourself time. Then we do our mole to mole ratio. Okay, how do I get the mole to mole ratio?
Just look at the coefficient.
I just look at the coefficient. So in this case, it's 1 to 1 to 1, right? Okay. Then we would do the number of moles, and then we would do the amount, and the amount was in grams. So fill in what they gave me. They gave me 0.200 grams there, right? So now I know all I have to do to get to moles is take this and divide it by that. And then that goes right there. The 4.34 times 10 to the negative third. So I know now if the reaction went to completion, the moles of this and the moles of this. Correct? Now, what if this would have been a 2 and these two would have been 1? What would I have had to have done to get the number of moles of these? Divide the number of moles by 2. Okay? This is what your homework sheet's supposed to be on. Okay? Limiting reactants. So you can find limiting reactant and do that because they're probably going to give you a stoichiometry problem somewhere just like this. Okay? All right, we'll finish this up tomorrow. No, we won't. We'll finish this up Wednesday. I won't see y'all tomorrow. Good luck on the ACT.